We have a region bounded by these graphs, and we want to revolve this bounded region about the y-axis or the vertical line x equal to 0. So this is the graph for y equal to the square root of x. This is the line y equal to 0. This is the vertical line x equal to 4. And this is the y-axis and also the axis of revolution. So what we want to do is revolve this bounded region around the y-axis and use what's called the shell method to find the volume of the solid of revolution. And again, just like before, what we'll do is we'll fill the shaded region of the bounded region with rectangles. And then what we do is we revolve each rectangle about the axis of revolution. And when we revolve it, we'll get what's called a shell. So we revolve this first rectangle right here around the axis of revolution, and we get a shell that looks like this. And then the next rectangle, the shell would look like this one. And then rectangle number 3, we have a shell that looks like this. And notice the shell is nothing more than it's just the outside cylinder and inside cylinder. And then for the fourth rectangle, we get this shell. And so what we're going to do is find the volume of each shell and then add the volumes of the shells together. And that will give us the volume of the solid of revolution. And so one more time, that's shell number 4, shell number 3, shell number 2, and shell number 1. And now we'll find the volume of each shell. So first, let's label some midpoints. So from here to here is 4. From here to here is 4. And so the midpoint right here, the first subinterval is from 0 to 1. The second subinterval is from 1 to 2. The third interval is from 2 to 3. The fourth interval is from 3 to 4. And then the midpoint right here would be 0.5, 1.5, 2.5, and 3.5. And we'll call those midpoints, we'll use the letters T sub 1, T sub 2, T sub 3, and T sub 4. And now let's look at the height of each shell. So this is shell number 3. And remember that this function right here is y equal to the square root of x. And so the height, to figure out what the height is, we use the midpoint right here. So the midpoint right here is 2.5. And so the height would be f of 2.5. And so the function is f of x equal to the square root of x. And so the height with this shell number 3 would be the square root of 2.5, because the midpoint right here is 2.5. And so the height would be f of 2.5, which is the square root of 2.5. And then now we look at shell number 1 with the other shells. So for shell number 1, the midpoint right here is 0.5. And so the height would be f of 0.5. So f of 0.5 would be the square root of 0.5. And then for shell number 2, the midpoint is 1.5. And so the height would be the square root of 1.5. And then for shell number 4, The midpoint right here is 3.5. And so the height for the fourth shell is the square root of 3.5. Now the thickness of each shell, which is the same as the width of the rectangle, so we'll call it delta x. And so each shell right here, the width or the thickness of the shell will be 1. So for shell number 3, the thickness or the distance between the inner cylinder and the outer cylinder. So this is 1. This is shell number 4. The thickness of the shell or the width of the rectangle is 1. This is shell number 2. The thickness of the shell or the width of the rectangle, which is also 1. And so the thickness of each shell is 1. Now let's find the volume of the of shell number 3 first, and then we'll find the volumes of the other shells. So for shell number 3, the midpoint right here is t sub 3, which is 2.5. The height is f of t sub 3, or the square root of 2.5. The outer radius, or the radius of the outer cylinder, will be from here to here, which is 3. And then the inner radius, which is the radius of the inner cylinder, is from here to here, which is 2. And then the average radius is the distance from the axis of revolution to the middle of the shell, or this right here we call it t sub 3, and this is 2.5. So inner radius is 2, outer radius is 3, average radius is 2.5. And so to get the average radius, we just do the outer radius plus the inner radius and divide it by 2. And that will give us the average radius. And to get the volume of the shell, we'll find the volume of the outer cylinder and then find the volume of the inner cylinder and then subtract. So it'll be the volume of outer cylinder minus volume of inner cylinder. And remember that the volume of a cylinder is just pi times the square of the radius times the height. So we have pi times outer radius times the height, and then minus pi times inner radius square, and then square here also times the height. Notice that both the inner cylinder and the outer cylinder, they both have the same height. And then we'll go ahead and factor out the pi and height, and then we have pi times height times the outer radius square minus the inner radius square. But this is the difference of 2 square, so we'll factor it, and this becomes like this. And then just rearrange things a little bit. And so this is pi, this is height. And then for this term right here, we'll rewrite it like this. So this is 2 times, and notice that 2 divided by 2 is just 1. And this is called the average radius. And so in this case, the average radius is 2.5, because it's 3 plus 2 divided by 2, which is 2.5. And then the thickness of the shell, in this case, is the width of the rectangle. But notice that the thickness of the shell is also the same as the outer radius minus the inner radius. So this is the outer radius, this is the inner radius. And so we do outer radius minus inner radius, we get thickness of the shell. And so this becomes the thickness of the shell, and this becomes the average radius. And so we end up with 2 pi times the height of the shell, and then times the average radius, and then times the thickness of the shell. The height which is f of t sub 3. T sub 3 is the midpoint for the third shell, for the third rectangle. And then average radius, which is t sub 3. And then thickness of the shell is delta x. And so we end up with 2 pi, and then the average radius is 2.5, and the height of the shell is the square root of 2.5. And then for this particular problem, the thickness of the shell is 1. And so this is the volume of shell number 3. And in general, for the ith rectangle, t sub I is the midpoint of the ith subinterval. And then, but also notice that t sub I is also the average radius when the axis of revolution is the y-axis. And then we'll deal with cases where the axis of revolution is not the y-axis later. And then f of t sub I is the height of the shell or the height of the rectangle. And so one more time, from here to here, that's t sub 3. And then the height of the shell is f of t sub 3, or it is the ith rectangle. And then from here to here, it'd be some t sub I distance. And then the height of the rectangle is f of t sub I. And then the volume of the ith shell will be 2 pi times the average radius times the height times the thickness of the shell. And so it will be 2 pi, average radius is t sub I for cases where the axis of revolution is y-axis. And then the height is just f of t sub I, and thickness of the shell is delta x. And so for the other shell, so we calculated the volume of the shell number 3. The volumes of the other shells would be calculated similarly. So for shell number 1, it'd be 2 pi times the average radius or t sub I, t sub 1, which is 0.5. And then the height of shell number 1, so let's move to shell number 1. So the height of shell number 1 would be f of t sub 1, which is the square root of 0.5. And then thickness of the shell is 1. So this is the volume for shell number 1. And then for shell number 2, the volume be 2 pi, and then t sub 2, which is the average radius, will be 1.5, and then the height of shell number 2 is the square root of 1.5. And then the thickness of the shell again is the width of the rectangle, which is 1. And then shell number 4, for shell number 4, the average radius is t sub 4, which is 3.5. And the height of shell number 4 is the square root of 3.5. And then again, the thickness of the shell number 4 is just the width of the rectangle, which is 1. And then to get the approximate value for the volume of the solid of revolution, which is at the volumes of the 4 shells together. So this is the volume of shell number 1. This is volume of shell number 2, volume of shell number 3, volume of shell number 4. And so shell number 1, this is shell number 1. So we have, instead of 4 rectangles, if we have n number of rectangles, and then we would find the volume of n shells. So this is shell number 1, volume of shell number 1, and then up to volume of the nth shell, and then add them up. In summation notation, and then there will be the summation of 2 pi times t sub I. T sub I is the average radius, and then F of T sub I, which is the height of the shell of the ith shell, and then delta X is the thickness of the shell. So one more time, this is the average radius of the ith shell, this is the height of the ith shell, this is the thickness of the shell. And then if we want to get to the exact volume of the solid of revolution, then what we need to do is fill this solid of revolution with an infinite number of shells, meaning allow n to run to infinity. And so we allow n to run to infinity, and then we can define the exact volume as this. And then this becomes the definite integral of 2 pi, and then the t sub I be x, f of t sub I for f of x, and then times dx. And again, this right here, this formula only works if you have the axis of revolution as the y-axis. It's mentioned before, if the axis of revolution is not the y-axis, then we have to adjust the radius. And then the AB, that's just the interval, that's the ranges for x. So in this particular case, x ranges from 0 to 4, and so the a and the b, the limits of integration, will be from 0 to 4. And so to calculate the exact volume of the solid of revolution, and then we'll have the 2 pi, and this will be from 0 to 4, and then we have x. Remember that x here represents the average radius, and then f of x is the height of the shell, and then dx, that's the thickness of the shell. And so we have x and then f of x is the square root of x, and then times dx. Now this is x, the square root of x is x to the 1/2. X times x to the 1/2 is x to the 3/2. Antiderivative of x to the 3/2, add 1 to the exponent, so 5/2 plus 3/2 plus 1 is 5/2, and then dividing by 5/2. 2 dividing by 5/2 is the same as 2 times 2/5. So 2 times 2/5 is 4/5. And then times pi. And then if we plugged in the 4 here, we get 4 to the 5/2. And then if we plugged in 0, then we get 0. And so we end up with 4 over 5 times 4 to the 5/2 times pi. And this simplified to 125.8 over 5 times pi, which is approximately 80.42477. And so the volume of the solid of revolution, when we take this bounded region and revolve it around the y-axis, is 80.42